Hello everyone. This lecture video includes fundamental questions related to different types of bonds, degree of unsaturation, hybridization, and types of carbons from primary to quaternary carbons of the chemical structure in the question. Okay, let's look at the questions in detail. First question asks you to find the molecular formula of the compound, and there are carbon, hydrogen, and oxygen. Let's count the carbon first, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons in total. Next, we can count the hydrogen, but we don't see them in bond line or skeletal structure. Let's draw the hydrogen explicitly so we will not make mistake while counting them. There's one hydrogen here around the rings. And this carbon will have 2 hydrogens. This one, there's 1 hydrogen here. So there are 8 hydrogens in total, and we see 1 oxygen with 2 of the lone pair electrons. So the molecular formula for the compound is C10H8O. Moving on to the second question, the number of sigma bonds can be counted as there are 1 sigma bond between the atoms. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 sigma bonds in total. The keynote here on counting the sigma bond is as there is only 1 sigma bond between molecules, no matter whether they are in single, double, or triple bonds, we can just add up all the number of the molecules to double check your answer, which is 10 plus 8 plus 1, which is 19. We didn't count the second bond in the double bond and second bond and third bonds in the triple one because they are the pi bonds. We have 1, 2, 3, 4, 5, 6 pi bonds in total. For the degree of unsaturation, 1 degree of unsaturation is equivalent to 1 ring structure or 1 double bond. Also, 2 degrees of unsaturation is the same as 1 triple bond, 1 ring and 1 double bond, or 2 rings, or 2 double bonds. We have 1 ring structure and 4 double bonds, which add up to 5 degree of unsaturation, and a triple bond as 2 degree of unsaturation, which we will have 7 degree of unsaturation. Hybridization is the idea when the atomic orbitals are fused to form newly hybridized orbitals, and to find it, we first need to see how many atoms are connected to the carbons. So for this carbon here, it is connected to 2 of the carbons and 1 hydrogen, which makes the carbons to have sp2 hybridization, and the same for the carbon on the right here. There are 2 carbon and 1 of the hydrogen connected to these 2 carbons. Same for these 3 carbons, that they are also connected to 2 of the carbon and 1 hydrogen. For this carbon on the ring, it is sp2 hybridization, but this connects to 3 of the carbons. Whereas this one is sp3 hybridization because it connects it to 2 of the carbon and 2 of the hydrogen. These two on the right is sp hybridization because they're connected to 2 of the carbon. This carbon here is sp2 hybridization, but this carbon attached to 1 of the carbon and 1 of the hydrogen and 1 of the oxygen. So there are sp hybridization and sp2 hybridization and sp3 hybridizations. Primary, secondary, and tertiary carbon can be identified by finding the number of carbons connected or attached to a carbon. When there is one carbon attached to the carbon, just like this carbon here, is called primary carbon. When there are 2 carbons connected to the carbon, such as all these carbons that I circled in yellow, those are the secondary carbon. Lastly, there is one tertiary carbon on the ring we saw earlier, and this is the tertiary carbon. In this question, there is no quaternary carbon, but a simple example of quaternary carbon is the central carbon of 2,2-dimethylpropane. And looking at the molecular structure of it, looks like this. And the central carbon here would be the quaternary carbon, and the rest of the 4 carbons in green, they are the primary carbon. Thank you very much for watching the video, and good luck on studying.